software starter. So
Hey.
click on this to bring it up. And once it's up, you will want to start your run. You go to File, you go to New Workflow. And that's how you start your run. Now, you can go with one of these default templates, and you just pick one based off the parameters you want. They have a short description on here saying what they are. If you have done a previous workflow that is similar to what you currently want to use, then you can go to Historic Workflow, and this will list all of the previous workflows that you've done before. This has all the same parameters as what you've done in the past.
I was going to share this video with you too.
Yeah, let's do both. I already missed some.
And you can just pick any of the previous ones that you've done, and you can modify that as you will.
Okay.
So I will just go ahead and pick one of these just to show you guys. I'll set it for you can set whatever number of reactors you want, 1 through 8.
Okay.
So I will go ahead and just say 2.
Yep.
And I will open this workflow. Now when it brings you to this screen, you can change the names of your vessels. You can change which ones of the vessels you're going to use. So if you wanted to use Unit 3 and Unit 7, you can do that. If you wanted to, whatever ones you want. Let's say Unit 3 and Unit 8. You can also change the names of them. Normally I would change this to the batch number. So you can change those at will as well. The identifier here is the name of your run. You could just use the date and the client, or you could use an identifier number if the client gives you one of those. For Calion, they always use a K number identifier. And then on this side, you have your different preparation steps. You can select the different calibrations you want to do. pH calibration we usually do every time. Pump calibration we do occasionally, particularly if we make any changes to the tubing or rigs that we have hooked up. DO calibration we also do every time. CIP can be done if you want to clean the tubing using ethanol or base or anything like that. And I usually include a cleaning step at the end because it just makes it more convenient for cleaning the tubing. You can clean the tubing manually, but the cleaning step means that you can walk away without issue. Alright, so I'm going to just go ahead and save this. Actually, I'll just call this test. And I'll save this. Save it. Sure. It always takes a little while to load between each portion of your setup. So the next thing that will show up is going to be a screen that will show you your control options. When you actually get to the part where you're running your fermenters, this will be the different parameters it will run with. So you have your DO control here. If you select here, this lets you choose what value you want the DO to control to. So if you want to have the set point at 30%, then you can just enter this as a constant value under data here. You can also select the type of control you want. You can set it as a data table so that it changes the DO set point at different times. If you do set it to data table, it lets you enter the time points here in the DO that you want at that time point. You can also set up functions. That's considerably more difficult and requires you to input things using I forget what particular language they said that you have to input it in, but it's a little bit trickier. And you can also look at the graph that shows you how it'll change over time. You can also click on DO at the top here, and you can check the different control parameters. You can change the p-value, which is how rapidly and how strongly it will respond to any needed change to control. You can check the cascade parameters, so this will allow you to determine when it responds with increased agitation, when it responds with increased gassing, and when it responds with increased oxygen percentage. So oxygen here, increased flow rate here. This shows a graph of all of them. And you can see here, this red is for agitation, so during the initial stages of response, that first 40% response, it just increases agitation. And then this blue here, that's your oxygen percentage. So after that initial response, it will increase your oxygen percentage. And that's how we typically have it set up, is around 30% DO. We would change that depending on what the client wants. And then we have the cascade set up so that it increases agitation first, followed by an increased oxygen percentage. And we typically use a steady flow rate for gassing. Most clients want the gassing rate to remain about the same. And then for pH, we have a very similar set of controls for that. You can use the same sort of different control schemes. You can enter your data for what set point you want. You can look at the graph. You can also use different triggers so that you can have the pH control start with different parameters setting for its start, and also turn off with different parameters set for its switching off. And likewise, you can have it change how it interacts with the acid and base pumps. You can adjust the agitation, gas flow, oxygen percentage, all those things independently, but in most cases we leave those controlled by the cascade linked to the DO, so you would just adjust them with the DO controller there. The feed we usually have on either a constant value, in which we will just change this value here, or we have it on a data table in which we just enter the values over time. Any exponential feed, you can take an Excel sheet and you can just copy paste everything from it directly into here, and that'll make it very easy to do an exponential feed, or pulse feed, or whatever other type you want. So if you look at the graph here, we have an exponential feed that switches to a pulse feed after a certain time, and then after a certain time it turns off. So it's very easy to do even fairly complex feed profiles with this. Here's the temperature. We actually have a temperature for this run where it switches partway through, goes from a higher temperature to a lower temperature, but likewise you can change that to whatever you want as well. All right.
And what's the trigger for temperature?
For
the time component?
It's also just time currently.
So it's not looking at induction, or you're not inducing anything in this case?
In this case, it just has a set induction time at 24 hours, and so a little bit before 24 hours, it will start to cool down to a lower temperature for induction.
To 72.
You can, on each of these things, you can select where it says trigger here, and you can tell it to trigger based off of different things.
Okay.
You can set that based off of time, you can set that based off of a number of different variables.
Right.
And you can set different parameters based around it triggering. You can set it so that it can trigger multiple times, and a number of different parameters for that.
All right.
But in this case, everything seems good, so we will go ahead and save that over here, and then we will continue on to the next screen. And this will be our first calibration procedure for pH. So for this, we'll say yes, we do want to do the pH calibration. And now we will get pH probes.